Hi there. Today we are going to solve systems by substitution, and this is the second day of it. So we're doing a couple that may be a little more complicated or a little harder of a setup. So we're going to start with number 1 here. We have x equals 3y and x plus y equals 6. So first thing with substitution, you want to look for the equation that has a variable by itself. So you can see, okay, x is already by itself, and that's equal to 3y. So I'm going to plug in this 3y for x down here. I'm substituting that in. So I'm going to have 3y plus y equals 6. And then combine your like terms. So 3y's plus one more y would be 4y. Divide by the number in front of the variable. So y equals 6/4. Let's reduce that. So 6/4 would equal 3/2. Okay, so that's my first part. Now I have y equals 3/2, so I have to plug that back in to solve for x. So you want to plug into the equation that looks the simplest to solve. So if you're looking at both of these, I would rather multiply 3 times 3/2 than have to subtract, get like terms, common denominator, all that stuff. So let's plug it into the first equation. So I have x equals 3. That's just from above. And now I'm going to plug in 3/2 in for y. So 3 times 3/2. Okay, so let me rewrite this. So 3 times 3/2. If you like to write 3 over 1, you can do it that way. So top times top is 9. Bottom times bottom, 2. And that's as reduced as I can have it. So x equals 9/2. And now I have to write my solution as a point. So I always write x comma y. So my x we have here is 9/2. And then my y up above here is 3/2. Okay, so that is my solution for number 1. Those have fractions in it, and we reduce them as much as we can. So we are done. Nice work. Okay, number 2, again, we want to look for the variable that's by itself if there is one. So I see, oh, x is by itself right here. Okay, so 2 plus y is equal to x. So I'm plugging in this 2 plus y down here for the x part. So I have 2, and then I have to put parentheses because this x is 2 plus y now. So I need to put parentheses around that, and then plus 2y equals 4. Okay, so this part in the parentheses is the part I substituted in. Okay, so now I'm going to get rid of it. I'm going to distribute. So 2 times 2 is 4. 2 times y, 2y. Okay, and then combine like terms. So I'm going to add my y. So 2 plus 2 is 4y. I still have that 4. Okay, and then I'm just going to solve this. So I have 4y equals 0. I still have a variable, so I'm still going to divide by the number in front. So y equals 0. Don't say that there's no solution. That's not true. We still have a letter here. Okay, so I have y equals 0. And now I'm going to plug back in to find x. So let's look at both of our equations. This top one looks much easier to plug into. It's simpler. There's not as much multiplication. So I'm now going to plug in 0 for y right here. Okay, so I have now 2 plus, instead of y, I'm plugging in 0. So 2 plus 0 is 2. X equals 2. Well, that was easy. Okay, so now my solution is x comma y. So my x is 2. My y is 0. So that's my solution. And like we have been doing with graphing, you are welcome to plug both of these numbers in to both equations to make sure you are right. Then you know you get 100%. So I plug in 2 for x, 0 for y in both equations, and both sides should be equal to each other. Okay, we're going to do a couple more. Let's go down to number 3. Okay, so we look at number 3 and we look for a variable that's by itself. I don't see one that is by itself. So we have to make it like that. The easiest one to work with looks like this bottom equation. If I solve for x here, I can just add y in one step. So I'm going to add y to both sides. So now I'm left with x is equal to y minus 4. Okay, so now I'm working with this equation and the top equation. This guy in the middle, I'm not using it right now. I just changed it to this form. It's the same equation, just a different form. Okay, so now I'm going to look for my variable by itself. That's y minus 4. So I'm plugging this in for x up here. So I have negative 2, and now times y minus 4. And then I have plus 2y. I'm just looking up right here. Is equal to 8. Okay, and now, like we did in the last problem, I'm going to distribute. So I have negative 2y plus 8 plus 2y is equal to 8. Okay, let's combine like terms. Negative 2y plus 2y. Oh, that's 0. Okay, I'm not even going to write it. So I'm just left with 8 equals 8. Ooh, okay. Now there is no letter. There's no variable. Earlier in problem 2, we still had a y. In this case, it's just 8 equals 8. That is always true. That's a true statement. Those numbers are the same. So now is when you would write infinitely many solutions. So when we graphed these problems, we showed you what this looked like. But if we have an infinitely many solutions scenario, say I'm graphing this one here, like that. That's my line. If any number, or there's any number of answers that could work, that means that these two equations are actually the same line. Okay, so if you solve both of them for y equals mx plus b, you would get the same equation. Okay, let's turn over to the back side. We're going to do one more, number 5. Okay, we're going to look for the variable that's by itself. I don't see any variables that's by itself. Okay, so we're going to have to solve for one to be alone. This is where it gets a little trickier because you have to decide which one's best. Okay, so say I solve for x here. I'm just going to talk through it a little bit. I'm going to subtract my 3y's. Then I have to divide everything by 2. If I look at these coefficients, like 3 and 5, can I divide those by 2 nicely? No. Yeah, you're right. There's going to be weird fractions. If I look down here, say I just solved for x here. So I added 6y over, and I divide everything by 4. It's a little bit nicer. Like 12 will divide by 4 nicer than all of this up here. So I'm going to work with this bottom equation actually and solve. I'll solve for x. It doesn't matter if you solve for x or y. You actually get to pick which one you prefer. Okay, so I'm going to add 6y over. Okay, so now I'm left with this, and I have to get x by itself, so I'm dividing everything by negative 4. Okay, so x is equal to 6 divided by negative 4. I'm going to write the negative on top, so negative 3 over 2, y. And then positive 12 divided by negative 4 would be negative 3. Okay, so this is the equation I'm working with on the bottom, and then I'm also working with this top equation. So I need to plug in this part here for x. So I have 2 times negative 3 halves y minus 3. That whole thing's in parentheses. And then I have this part here. So plus 3y is equal to 5. Okay, so 2 times negative 3 over 2. I'm doing top times top. So I have negative 6. And then bottom times bottom would be 2. Then I have 2 times negative 3 would be negative 6. Plus 3y equals 5. Okay, let's reduce a little bit here. Okay, so negative 6 over 2 would be negative 3y. Everything else stays the same. combine like terms. Oh, again, I have 0y. Okay, I'm not going to write that. So I'm just going to write what I have left. -6 is equal to 5. Is that true? No, those numbers are not the same. So not true. So this is when we write no solution. In these special cases, like infinitely many solutions and no solution, you do not plug back in to find the other variable because we actually didn't really solve for variable here. We just had, oh, it doesn't work, no solution. So if you think back to the graphing chapter when we did this, that means that we have two parallel lines. Okay, so they're never intersecting. That's why we can't find an answer that works for both of them. Okay, so this is it for the day 2 of substitution. Make sure you're working on your classwork and checking those answers that you have the correct points for each problem.